Hello, everyone. Welcome to this month's Developer Office Hours. My name is Dennis, and I will be talking about Gateway today. If you have any questions, let me know in chat. The rules are the same. Just post a question in Discord chat, and let me know if you wanna join the stage to have a discussion about it. So yeah, let's dedicate the whole call today to the gateway. Uh, as you may or may not know, Zeta Chain is transitioning into to a new architecture, basically that we called Gateway. And what this means is you can actually read it in the updated docs, but kind of a quick overview of what's going on. Basically, in the past, or in the current testnet, actually, you deploy Universal apps on Zeta Chain and interacted with them from connected chains using TSS if you wanted to send native assets and ERC20 custody contract for supported ERC20 assets. That worked, but what we wanted to do is provide a unified entry point for developers to interact with Universal apps. So each chain should have a single contract that you interact with that propagates the contract calls or token deposits to the Universal app that you have deployed. And we've done just that with the gateway. So now every chain has a gateway. It might be a smart contract, for example, on EVM chains. They're all smart contract enabled, of course. So there's a gateway contract on chains that are non-smart contract enabled, like Bitcoin. There's a gateway address. On Solana, there is a gateway program, pretty much a contract, but it's called a program. And there's going to be one on Ton as well, and on other chains that we connect. And you can do anything, like everything you wanted to do with the Universal app, you can do through this gateway, which is very convenient and makes the API much cleaner. So we have detailed description of how gateway works. So there's also a gateway on Zeta Chain as well if your contract needs to make outgoing calls to connected chains. So for example, on Zeta Chain, you can read more about how gateway works on Universal EVM on Zeta Chain, and on something like EVM, it works differently. So on EVM, you have methods like deposit and call, so you can execute the logic in a very granular fashion, right? You can just make your call without transferring tokens. That's probably a bit less useful than something like deposit and call because most action requires tokens. So I think this was going to be the most used one. This API is not set in stone. We're actually making some changes to it, and I'm probably going to be talking about them in the next office hours in October. But right now, I wanted to explore the gateway with you and how you can interact with it, and also Solana, because we've recently added Solana testnet, so you can actually make calls to Universal apps from Solana DevNet to Zeta Chain's testnet. So without further ado, let's get into the tutorials, because I think it's much easier to understand how it all works based on real examples. Let me check if we have any. It doesn't seem like we have any questions, so let's go ahead and dive deep into tutorials. So as you can see, the tutorial section has been updated. We now have tutorials that work on LocalNet, which use the gateway, and we are also keeping the old swap on testnet tutorial as well, because gateway is not yet enabled on testnet. That's why if you want to test something check out something on testnet, you go and look up this tutorial here. It's using TSS, and everything that has local nets in the name is using gateway, because right now you can only use gateway on local net. So let's go ahead and open example contracts. You can, of course, clone them from GitHub, which is GitHub example contracts. Just clone the repo. It has two directories, examples and Omnichain. Omnichain contains the, so to speak, legacy contracts, the swap, and examples are the gateway contract. So eventually this directory is going to be deleted, and we're only going to have examples. So I propose we start with the Omnichain swap and Solana, just because it takes some time to process, and I want to initiate this process as soon as possible. So, okay, let's go into Omnichain swap, compile the contract. We're going to be using swap to any token contract. It's the same one we had for a couple of months now. It allows swapping tokens between blockchains, including Bitcoin, Solana, and it also allows you not to withdraw tokens, so you can swap directly into ZRC20. And fun fact, when I was upgrading this tutorial for Solana, I actually didn't need to change anything in the source, which is pretty cool. So it worked out of the box exactly the same way. And this was because I used ABI encoding on Solana. So the same logic that is used to decode messages from EVM worked on Solana, because from Solana's side, I just used ABI encode, which got me thinking that we should be using ABI encode standard across all chains. We need to investigate this a bit further, specifically how costly it is to encode on like messages on Solana using ABI encode. Are there libraries for this? But from the front end side, it's super simple. You can just use Ethers.js or any other library that supports ABI encoding. So eventually, this code block should also go away, because we're going to be defaulting to Bitcoin's inscription, so storing data in witness data section of a transaction, which will allow us to use ABI encoding as well, because it's longer. It doesn't fit into 80 bytes that we're currently using for Bitcoin using OP return, but with inscriptions, you can actually send larger pieces of data, which is very convenient for ABI encode. So hopefully, eventually, this is just going to be the only code you need, and every transaction from every chain is going to be just using ABI encode. Maybe not. We're going to see. Okay, so let's deploy this contract. I'm going to be using swap to any token and deploy it on Zeta testnet. I already have private key in the .env file. If you don't have one, just use npx hardhat account, save, and then use a faucet. So we've deployed a contract on Zeta Chain testnet, and now we can use the hardhat command. We have interact Solana task, which is actually here directly in the repo. So interact Solana. It requires an amount, 0.1, swap a small amount. Contract is going to be the contract that we deployed our swap application to, and recipient is just going to be my own address here. So for target token, we're going to be using ETH, Sepolia ETH, to copy the ZRC we have a tokens command. It's a bit Okay, that's better. Sepolia ETH, this one. Just copied the target token address. It's also available in the docs as well, but yeah, you can access it from the tokens command in the terminal. And withdraw. I mean, we're not going to withdraw defaults true, so that just works. So this looks good, I think. Target token recipient. So I've already set up Solana on this machine, and I have tokens. So I believe that's Solana balances. So Solana balance. If you don't have it set up, just type Solana CLI and follow instructions on their website. Well, not this instruction, but somewhere here. It's actually interesting that they're Solana CLI. Yeah, it does point to a broken link. Okay, the second one should work. Okay, just follow these instructions and get some SOL tokens from the faucets available. And by default, the private key is stored in this id.json, and it's just going to be using that. So let's send this transaction. See if it works. Take some time because the way it works, by the way, is it just uses this deposit function that essentially creates a wallet, encodes parameters, and broadcasts the transaction. Nothing special about it. So, as I mentioned, Solana has a gateway program, and this program has deposit method function. You can actually read more about it in protocol contracts Solana repo. So the program is actually here, and you can. So yeah, we're calling this deposit method, which accepts SOL tokens and emits an event which Zeta Chain observers observe and vote on it on Zeta Chain. So we broadcasted the transaction, and now we can go to Solana DevNet Explorer and search for a transaction hash. This is super convenient because we see that the program returned success, so we know that the gateway accepted the tokens, and we sent however many LAM ports, which is the lowest amount on Solana, to the gateway. So now we can go to in TX hash. This has actually been updated to inbound TX hash to CCTX data. You can already see that the transaction has been processed, right? So it's super fast. We can actually do it again and see how fast it works. So let's copy. Let's wait for it to be processed. I just wanted to check how fast it is. Well, I mean, it still takes some time for ATX to be processed on Solana, but it's definitely, it should be faster than most other blockchains out there. The reason I'm not using transaction tracking is because the swap example that uses TSS uses an old version of the toolkit. Okay, so it took what, like 20 maybe seconds, 20, 30 seconds. So it's definitely very fast. And now it hasn't been processed on the destination token, destination chain, which is Sepolia, but it has been already processed on Zeta Chain, which is pretty cool. So it's really fast, and the function here is in the repo. In the future, I mean, in the up-to-date version of Toolkit, the pre-release version, I've moved the task into the client here. So, and it was renamed Solana Deposit. So this is going to be removed once I ship the latest version of the toolkit. This is a bit more, it has some checks. So yeah, definitely going to be improved in the future. So yeah, this is how you interact with a contract from Solana. Super simple. Just execute a command, interact with the gateway, and that's it. We're not going to be waiting for the token to be received on Sepolia testnet, but it has been processed on Zeta Chain, so that's good. Okay, any questions? I don't see any questions. Moving on. So let's take a brief look at how this is structured. So here we're actually using ZRC directly to withdraw tokens. And let's see. Yeah, we're passing system contract, which is the same, but like the biggest difference between the swap and the swap that uses TSS and the swap that uses Gateway is how we withdraw tokens from Zeta Chain. So let's check out the swap that uses Gateway. It's on the right. It's pretty much the same thing, except when we withdraw, we actually call the gateway instead of ZRC20. We still approve ZRC20 tokens, but withdraw is now called on the gateway. So this is the biggest difference here. And of course, there are some changes, like we pass the gateway address. Hopefully this will be just inherited from universal contract, so you wouldn't need to pass gateway system contract. System contract eventually is just going to go away, and we'll have a contract registry contract. But yeah, this is also going to be streamlined. Right now we're importing a bunch of things from the toolkit and wherever, but yeah, going to be improved. But for now, still looks pretty good, pretty compact. Let's go into the swap that is powered by Gateway. It's not compatible with the current version of the testnet. It's going to be in, I don't know, a few weeks. But right now we can use LocalNet for this. So for those who are not familiar with LocalNet, it's a super handy local development environment which spins up an Anvil EVM chain, deploys protocol contracts, specifically the gateway and other contracts on it, and it kind of pretends that you have multiple chains and uses gateway to pass data between these chains. It's still running on the same chain, that's why it's super fast, but it lets you build and kind of simulate the environment of a real testnet without actually spending testnet tokens or waiting for transactions to be processed. So let's go into the examples swap. I'm not going to go into the hello example because it has been covered in the video that I posted recently in dev announcements. So you can watch this video if you want to kind of get an intro on what LocalNet is. And right now, let's just focus on the swap instead. Looks like we have a question. Info like this should be placed on YouTube to catch third-party devs. Actually, all our dev office hours are recorded and posted on YouTube, so it's a great suggestion. Thanks for that. We're going to be posting it on YouTube. And yeah, of course, good idea. Okay, so we have our swap example here. Let's start LocalNet. So it deploys our protocol contracts, and you can get these contract addresses here, which is super handy. And now what we're going to be doing is let's open a new terminal for this. let's compile the contract and deploy it to localhost because localnet is running on localhost. Okay, now we got contract address. This contract address is actually consistent between localnet restarts, so it's going to be the same unless we add more contracts to localnet. So it's somewhat consistent, but don't rely on it for being 100% consistent all the time. Okay, now that we've deployed the swap contract, let's use one of the commands we have here. So we have EVM call, deposit, and deposit and call. We're going to be using the deposit and call one. EVM deposit and call. And let's fill this out. This is a bit more involved because it's a general purpose function that works with any contract. What I'm going to do next is actually create a task that will just import this function and make it specific for swap. So you wouldn't have to pass types and values manually. It's just going to wrap this function in something more natural. So that would be like EVM swap or something. But right now we can use that. The advantage is that it works with any contracts. It's very, very versatile. So the amount is going to be 1. We're going to be swapping native tokens, so without ERC20. Gateway EVM receiver is the contract on Zeta chain, which is 5933. Types. So this contract expects to receive. Actually, you know what? Let's. Yeah, let's use this one. Never mind. No, actually, let's deploy the other contract, the vanilla one, the swap, because we're not going to be using swap to ERC20, which is just a simpler contract because we don't need to pass the withdraw. We're just going to be passing two values, which is target token, an address, and bytes recipient. A bit easier. So receiver is going to be this contract address, types, address of the destination token, and bytes for the recipient. So for the destination token, we're going to be swapping ETH to USDC. So the destination token is going to be ERC20 USDC. And recipient is just going to be me. Don't forget to type network. It's actually, it should be before, because these are values of arbitrary length, right? So specify network and localhost. Okay, let's go back to the local net, and we see that the gateway received a deposit event. So this is on EVM. Zeta chain reports that the universal contract has been called. The contract executed successfully, and it called the withdrawn event. So if we go back to the code, we have we called gateway withdraw, and when gateway withdraw is called successfully, it emits a withdrawn event to let Zeta chain validators know that you need to make a withdrawal. And on EVM side, this amount of ERC20 tokens were transferred from custody to the recipient. So this is pretty cool. It's super fast, and you can like experiment with the contracts. You can, of course, it's not limited to swap. You can build anything you want. We can also actually try swapping ERC20 tokens. I actually don't see the ERC20 address anymore, so let's restart localnet. Localnet is so fast that you can like even restart very quickly. Don't worry about testnets. So let's deploy it again. And now update the receiver. And now let's use ERC20. So we were swapping ETH to USDC, but now we're going to be swapping ERC20 USDC. Again, of course it's not USDC, it's just a dummy ERC20 token, but it's easier to label them somehow. And the destination is going to be ERC20 ETH. So this swaps ERC20 token for ETH. Now let's go back here. And it's the same. The gateway emitted the deposited event, the withdrawn event was emitted, and now it transferred this amount of native gas tokens from TSS to the recipient. It still says TSS, even though we now use gateway for everything. There's still TSS address on each chain, which represents the custody of Zeta chain validators of the tokens deposited to Zeta chain from connected chains. But yeah. Okay, let's go back to Discord to see if we have any questions. My internet is not stable. So sorry about that. Well, hopefully it didn't impact the quality of the video. If it did, this is recorded, so it's going to be posted on YouTube. Sorry about that. Maybe that something is wrong with Discord because my internet connection seems to be working fine. But yeah, it's going to be posted on YouTube. So okay. So we've covered the OmniChain swap legacy example with Solana, how to interact with contract from Solana, and we also used the localnet to experiment with the swap tutorial example that is now powered by Gateway. Hopefully this was useful. I think this is it for this episode of Dev Office Hours. If you have any questions, feel free to type them in chat. Okay, see that Finisher is typing. Let's wait for that. Also, if you want to see more specific content next time, let me know in Dev General. Like if you want a partner project to present something, let me know. Also, if you are building something, Dev Office Hours is a good way to have a conversation about the questions you might have. But yeah, Gateway is a very cool upgrade that brings a lot of new features, and I'm hoping that developers can really leverage that once it's shipped to testnet. I have a question. Well done so far. I have a question about not directly about development, but about our product in our earlier talks. Okay, sure. Let me add you to the stage and we can discuss this. Finisher, you should be invited to speak. I mean, you can type your question. Oh, hello?
Hello, am I audible?
Yes, I can hear it.
Oh, awesome. All right. Hello everyone, and well done, Dennis, so far. Well, just like I said, my question is not directly technical question. But I just wanted to follow up on our last conversation we had with I think Kim regarding Zeta tokens and the developers grants. We haven't received a reply yet, and we are running into some time-sensitive challenges. We are currently in talks with a university here in Nigeria to explore how Glitz Fund is our product we are building on Zeta Chain, a fundraising app that uses Zeta Chain's Omnichain feature to accept tokens, different tokens, and where donors and someone donating can accept donations in different tokens and receive them in his um, selected token. So we're having talks with universities here in Nigeria on how they can integrate Glitz Fund to receive tuition payments from people worldwide. But we without access to these test tokens, we haven't been able to fully test our products, and this is putting our market entry at risk. Simply put, we are losing the opportunity to secure a strong partnership with the university as they expect results soon, you know. And regarding the developers grant, we also haven't received feedback. So we proceeded with our application yesterday, however, in hopes that the support will help us build quickly enough to meet the next school entry period. So that's just basically my question. Could you please maybe let us know if there is any updates on the matter, or if there's anything you need from us? I would really appreciate your feedback.
Yeah, thanks for sharing. If you can post information about the project and your contact information uh, in Dev General actually, and I will relay this information to. It's more of a BD sort of question, but yeah, I can ping other contributors and let them know about it.
All right, I'll do that soon. Thank you so much, Dennis.
Thank you. Okay, so next question: what is the schedule of stages and dev calls? We actually have events here. So if you go to Discord events, there are dev office hours up until, so the next one is on 22nd of October, and we also have the protocol dev planning here. You can also go to Luma slash Zeta Chain, so that's LUAMA Zeta Chain, and subscribe. Okay, I have been blocked from Luma, which, yeah, anyway, you can use Luma, um, or just subscribe in Discord. Okay, any other questions? I will be recording more screencasts and uploading them as well. But yeah, we have actually a lot of new features coming soon to Zeta Chain. Just kind of a refresher for people who just joined. We have Ton support in proof of concept stage. Super exciting. Ton is really popular, and we want to empower developers to build apps that are compatible with Ton. We have upgrades to staking coming soon. I'm going to be working on an example for that as well to stake tokens from Solidity, which is also going to be popular feature of Zeta Chain, because right now you can't do that. You can only do this kind of off-chain way because it's a Cosmos side of things, so it's not tightly integrated with Solidity. But that's going to change with the with the following upgrades. Okay, well, thanks everyone for joining. It was a pretty short call, but I hope you got some kind of understanding of how you can use Gateway. If you have any questions, of course, don't hesitate to reach out in Dev General channel for any tech related questions. If you see a bug in local nets, that might be the case. It's still very much work in progress. We're iterating quickly on it. So there might be some bugs in LocalNet. Um, but yeah, thanks so much for joining, and see you guys in the next one in October.